Question 16. So figure 6 shows a sketch of the curve with parametric equation x equal to 2 tan t plus 1, and then y is 2 sec²t plus 3, and then t is more than or equal to negative pi over 4 and less than or equal to pi over 3. And then line L is the normal to C at point P, where t is equal to pi over 4. We want to use parametric differentiation to show that the equation for L is y equal to negative 1 over 2x plus 17 over 2. So if it's about equation of the normal, we need to differentiate. And also we need to find what point P is. So let's find point P is first. So if t equal to pi over 4, so that means x equal to 2 times by tan pi over 4 plus 1. So 2 times by tan pi over 4. And then plus 1. So the x value is equal to 3. And then y equal to 2 times by sec square pi over 4 plus 3. So 2 times by sec square x is 1 over cos. So that would be 2 times 1 over cos of pi over 4 squared, and then plus 3. So that would be 7. So we know point P has coordinates 3, 7. And now we need to differentiate. So dy over dx is just equal to dy over dt divided by dx over dt. So dy over dt, we just bring down the power 4 and then minus 1 the power sec t, and we talk by the derivative of the chain. So sec t differentiate to sec t tan t. And then divide by, so dx over dt, 2 is just 2. Tan t will differentiate to sec²t, and 1 differentiate to 0. So if we simplify that, 4 over 2, that's just 2. Sec² is sec²t, so it all cancels out. So just 2 tan t. And then because we know t is equal to pi over 4, so that would be 2 times by tan pi over 4, which is just 2 times 1, which is 2. So which means the gradient of the line has to be negative 1 over 2. And then it's a show question. They want us to write that form. So we can just do y equal to negative 1 over 2x plus c. And then substitute in the points. When x equal to 3, y equal to 7. So 7 equal to negative 1 over 2 times by x equal to 3 plus c. So c has to be equal to 7 plus 3 over 2, which is 17 over 2. Then we have the equation y equal to negative 1 over 2x plus 17 over 2. That's all. And then part B, show that all points on C satisfy this equation. So because we have tan and sec²t, so I will just use 1 plus tan² equal to sec² identity. So 1 is just 1. Tan t is, so for this equation, if we minus 1 for both sides, and then divide by 2 for both sides, that's what tan t is, and square that will be tan²t. And then sec² is simple, just y minus 3 divided by 2. Just minus 3 for both sides and divide by 2 for both sides, that's all. And then that would be 1 plus x minus 1 square over 4 equal to y minus 3 over 2. So I will times by 2 for both sides. That would be 2 plus, so 2 times 1/4 is 1/2. X minus 1 square equal to y minus 3. So therefore, y is just equal to 1/2 x minus 1 square plus 3 for both sides. That would be plus 5. Hence, we should it. Okay, and then part C, the straight line with equation y equal to negative 1 over 2x plus k, where k is a constant, intersects C at 2 distinct points. And then part C wants us to find a range of possible values of k. So if it's about the number of intersection points, it definitely has something to do with the discriminant. So we just have to solve the simultaneous equation and then set up the equation for the discriminant to find the possible values. So equate them. We have 1 over 2 times x minus 1 squared plus 5 equal to negative 1 over 2x plus k. And then times by 2 for both sides. So x minus 1 squared plus 10 equal to negative x plus 2k. And then x squared minus 2x plus 1 plus 10 equal to negative x plus 2k. So x squared, so plus x for both sides, that would be minus x, and then plus 11 minus 2k equal to 0 if we simplify. So then b squared minus 4ac has to be more than 0. Then negative 1 squared minus 4 times 1, which is a, and then times by c, which is 11 minus 2k, more than 0. And then 1 minus, so 4 times 11, negative 4 times 11 is negative 44, and negative 4 times negative 2k is plus 8k. So therefore, 8k has to be more than 1 minus 44 is negative 43 plus 43 for both sides. So k has to be more than 43 over 8. So now we know the k has to be more than 43 over 8. So again, look at the diagram. Yeah, this is a parametric equation. It's a very easy to set up a check about the domain range. So once you work it out, you always need to check, is that the case? So the straight line is the normal, which is already drawn here, L. Yeah, so let me just draw it out to see whether, let me draw it again. So to see how many intersection points are there. Yeah. So since k is more than 43 over 8, so the smallest possible value or the lowest possible line has to be this one. So this will give us the tangent, which is only 1 section point. Yeah, so that's why as long as k is above that, that will give us more than 1 section points. However, if we draw a line parallel to L and then C, so this is only 1 section point. So that's not 2 section points. This is only 1, this is only 1 section points. This is also 1 section points. Like only this one give you 2 intersection points. And anything between those two lines will be 2 intersection points. Why? Because this is not a full quadratic curve. So if it's a full quadratic curve, then anything more than 43 over 8 will be 2 intersection points, like this, 2 intersection points, 2 intersection points, and then this curve will increasing forever, so always 2 intersection points. But that's not the case, because t is always more than equal to negative pi over 4, and less than equal to pi over 3. So this part does not exist at all. So the only part exists is what they sketched. That's why k has to be more than 43 over 8, but less than or equal to whatever the k value for this line is. Yeah. And then more than that will be only 1 section point because of the domain. Yeah. So we need to find out the k value for the upper one. Yeah, we need to work out the upper limit. So as long as we know what this point is and then substitute it into the straight line, we can work out the value of k. So to work out that line, so because x is 2 tan t plus 1, we know tan diagram is always look like this. Yeah. So smaller t give us a smaller x value. So you just have to plug in when t equal to negative pi over 4, you can work out that point. So if t is equal to negative pi over 4, then x is just equal to 2 tan of negative pi over 4 plus 1, which will give us negative 1. And then y is equal to, so substitute in, half times by negative 1 minus 1 squared plus 5. So negative 2 squared is 4 times half is 2 plus 5 is 7. So we know that coordinate should be negative 1, 7. Now if we plug into that straight line, because that point is a point on that straight line, so then when y equal to 7, x equal to negative 1. So 7 equal to half plus k. So k is equal to 7 minus 1/2. 7 minus 1/2 is 13/2. So that would be the upper bound. So that means the final answer, k, has to be more than the lower bound, which is 43/8, and then less than or equal to, because at that, for this line, it's still two intersection points. If it's more than that, it's one intersection point. So that means at that instant, it's still two intersection points. So k has to be less than or equal to 13/2. So that will be the final answer.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.